Oh, I will be talking about software engineering and project management, how you can successfully conduct yourselves in a team together with other people when you build software. So, my name is Matthias Rost, and I will be using this means of communication for the slides. I have a PhD in human computer interactions, so I know a lot about how we interact with computers in various different ways. But the question is, for this particular talk, what do I actually know about software engineering? And for that, I'll just give you a very short kind of summary of who I am in that regard. Um, I started programming when I was 6 years old on Commodore 64 and then eventually on Amiga and so on and so forth. So I've been doing it for quite some time. I have programmed a bunch of different things in my PhD. For instance, I was using programming as a way to build the stuff that I then studied. So I kind of envisioned what the future might hold in terms of technology and what we might be using to interact with the world. And I built that so I could test it into the hands of users. So I worked in a very designerly way or design-oriented way in that regards. Throughout this time, I've also been doing a lot of consultancy, because sometimes when you know how to program, other people might ask you to help them out with programming. So I've done that professionally as well. Um, for about 2 years, I also worked as a professional consultant and a digital strategist, where I helped clients and customers to work with the digitalization. And I worked then in software project, both as a programmer, um, but also as a kind of a person who oversaw the projects. So if you want a project manager, if you will. But I will talk a little bit more about what that means to me. So hopefully you get a picture of I hopefully know a little bit about conducting software projects. So then what is actually software and how does it come to being? Well, in a way, that software is this kind of thing that us as software engineers might be building. But software is also that thing that the users come to use. And so the question then becomes, how do we come to build that thing that users come to use, right? Um, and so when someone tells us build something, or when we ourselves go about and say, oh, we should build something, what is it that we actually do? Well, we either have some vague idea about we want to build something, we want something to work in a particular way, or someone is giving us a very concrete set of requirements that this kind of software should fulfill. But either way, it doesn't matter how it starts. Eventually, we're going to have to divide this up into something so that we know how to start building it. And that's the same if I were to do it myself or if we're a team with several people need to do it. We have to decide where to start. And how do we find these tasks? How do we find where we can start? Well, we kind of basically need to divide this up into something, into some parts. And the only way to kind of do that is to use our existing experience with building things. How were they kind of composed? What were they built up from, so that we can start building those building blocks, if you will. So we use our experience for that. Because how could you know what this thing is going to be composed of? How are you going to know that? And you cannot know that. You will never really know that. And it doesn't really matter how detailed the set of requirements for this final thing is going to be. The only real specification of what it's going to be that is detailed enough is actually the code itself. And the code itself is only there once it's actually done. And then you really don't need to figure out how to start it anymore because it's already there. So we have some way of dividing these things into tasks, right? And we use our experience to do that, but we have the tasks. So how do we decide, how do we divide them? How do we decide who's going to do what, right? And there are basically three ways, I would say, in which that people can, or projects can kind of work. And it's either that each member of the team work on one task at a time. So one task. one person. Okay, there's one way. Another way is for one task worked on by everyone. And that's called typically mob programming. So the whole team sits together in front of one screen, one keyboard, or virtually distributed, but in front of one piece of code, and you work on it together. And that's called mob programming. And the final way, or some version of this, is one task, two persons. That's called pair programming. Now, obviously, you're skilled people and smart, intelligent people. You understand there might be some spectrum here, right? But this is basically how you want to go about doing it. So it's, as a single programmer, or you work as a mob, everyone working on it, or you can work as two people. And they're all kind of good ways of doing it, and it all comes with the pros and cons, like everything in life. The pros and cons to everything. But to be able to talk about the pros and cons, you need to kind of understand, and we need to talk a little bit about what happens once the code is actually written. To write is one thing, and then it's going to run and then it's going to be read some other people and stuff like that. So when we write something, when we pick up a task, the task should be a clear description of what it is we intend to do, right? So we might have a task which is, let's see, we have some software, there's a menu in it, and we're going to add a link in this menu to go to another page, for instance. It could be a web page, it could be a mobile app, it could be some sort of desktop software, it doesn't really matter. But it could be add link in menu to page X. Okay. Now this might be a good task, right? Obviously, if you know a little bit more about this particular project, you would understand it better. But we just assume there is a project in which this makes sense. Okay. To page X. Now, when we have this task, it means that a person can start working on it. And a person can also say, oh, now I'm done. And the person knows that they are done, or can say that they are done, because they think that now this software has a link in the menu to page X. The condition beforehand was software where there was no link to page X, and now there is, right? So me as the programmer, if I was the programmer who did this task, I can say now it's done. But the team has to decide whether or not it's actually done. The team together has to do that, and you need to devise procedures for how the team decides together. And the team can now decide whether or not the programmer is actually correct about whether this is actually now complete by looking at the code, testing out the code, and seeing, will this add a link in the menu to page X? But making sure that this does this thing is not the only thing that the team has to agree on. The team also has to agree that the quality of the code is up to standard, right? Is this code easy to read? Is it easy to maintain? Does it follow the guidelines that you've set up for the project, for this particular project? And so the way we do that is by code reviews. That's typically done in all software projects, or should be done, definitely. And the code review is basically someone else looking at the code, right? There's someone or some people have written some code, someone else looks at the code to see if it does the thing it's supposed to do, does it have any side effects, does it have any bugs in it, and tries to do that. And the reason why we do it has multiple purposes. And the purposes is, one, it increases the quality of the code. So it's been shown in studies that if you do code review, it actually decreases the number of bugs in the software by quite a bit. So it increases the quality of the code. And not only with the bugs, it also makes it much more streamlined and increases the chance that we'll follow the style guide of the project. But often overlooked kind of effects of the code review are the second 2 points that I want to bring up. One is it distributes the knowledge about the code in the team. So if I write the code and no one else looks at it, it just runs there, I will be the only one who understands it. If there are changes needs to be done, I'm the only one who has to do it, or someone else can look at it again and then try to understand it. But if you already have that understanding in the team, then more than one person can come in and fix the bug or add a feature or whatever. So it distributes the knowledge about the code throughout the team. And lastly, it also increases the skill in the team, and it does it through this peer assessment, because code review is a style of peer assessment. I write some code, someone else looks at it, they will give me comments that this was really good, I haven't seen it before. It means that they learn from what I've done. But it can also be, oh, have you thought of this thing? Because I think this condition can happen, then this might not happen, and I might learn from that. But it could also be, oh yeah, I see you do it this way, but look here's some other piece of code that does it in a slightly different way. I think this might be better, and I will learn from that. Because we all have our own sets of experiences, and by communicating through this code and about this code, we can all learn together. So it increases the quality of the code. Quality goes up, plus, plus. Distributes knowledge. And it increases the skill. Oops. It increases the skill in the team. Again, plus, plus. We all know how to read code, right? Now the thing is that if it's only one person who's written the code, so if you work in this first kind of way, where one person works on one task, then the need for the code review is much greater than if the code was written by several people. And the reason of this is that the more number of people, eyes or minds that go into thinking about code, the better the quality of the code. Because if you're working together, you're already kind of reviewing each other as you go about it. The person by the keyboard is writing the code, and the person next to it is kind of reviewing it on a real-time basis. So that increases the quality of the code. And if you're working as a mob programming, you could argue that maybe there's no real need for a code review, because you've all been given a chance to look at it. Now, if you're doing in pair programming, you can still do the code review, but the amount of effort that needs to go into it might not be as great as it would have been if you were alone. So that's quite good, and good things to consider. Now, the code is done. We've written the code. I've said it's done. A set of reviewers have said, yeah, this is done. But that doesn't necessarily mean that it's done, right? Because we did say that software is this kind of stuff that we as software engineers build. Okay, but that was just one part. The other part is that software is that thing that users tend to come to use. So we need to give the users a chance to be able to say as to whether this software is done or this task is done or not. And how do you do that? Well, this is where you kind of go into some sort of testing or some sort of evaluation state, where you actually have this code, the code is done, okay, great. And then it goes to a QA, quality assurance, or some kind of testing phase. It could be designers involved, it could be anyone involved, a user experience designer, for instance. But that's a stage that needs to be done, right? So to summarize that kind of thing, the code basically goes from task to done through a series of steps. First, we have a little task. Then we go into coding that task, basically translating the task or the thing that the task should do into some piece of code. Then we go to reviewing this code. Then we go to test this code. And if everything comes to fruition, we're done, right? So we have a task, then we code, we review it, we test it, and it's done. That's kind of a simplified view from the point of view of just code. this software project is not just code. Software project is a bunch of different things. There are different stakeholders who are responsible for this. Typically, sometimes it's the team of programmers, but rarely that's the case. And there are also people saying, like, if it's a web page or if it's a mobile app, there's usually some sort of style goes in, some sort of design, visual design, graphical design. And they will probably also have a say in this, hopefully, right? And the way things are used comes into the hands of interaction designers. They typically want to have a say in this as well. But from the point of code, usually you do have a task and you do go about coding it. You go about reviewing that code. You go about testing the result of that code. And then you can say that it's done. So how do we come about to structure this sort of project then? And there are many different ways you can do this. If you heard about Scrum or Kanban, they are both kind of good ways to decide how to structure the code, how to kind of go about the day-to-day business. But it all comes down to some sort of tasks and how you do the tasks is still following this sort of procedure. The real important points here is to really meet regularly and make small decisions, right? So meet regularly. And make decisions, make small decisions. So meet and make small decisions, and do that together, right? So that's another important thing. Together, as the whole team, right? Because when you do that, it means that you're moving forward, and moving forward is really good. You don't want to stop. And moving forward in small steps means that it is not devastating if you take a step in the wrong direction. Because like I said, you never really know what code to write. You never really know what's going to be the right thing to do, how the structure is going to be and sort of thing. It can change regularly throughout the project. Okay, and through experience, you're better at making the better decisions, but you never really know what should be done. And so the best way is to make small decisions and do them regularly, because it means you can take a small step in the wrong direction, and then you notice that, oh yeah, this was in the wrong direction, and you do some course correction. You take another step back, and you do it fairly quickly. You barely notice that you didn't take a wrong step. If you instead wait and make big decisions, seldomly, then you're gonna have to take a huge step into the wrong direction, and you will only be able to course correct much later. And this is highly undesirable. This might even be after the deadline of the project. You won't even be allowed to course correct, and you might have to live with this this step in the wrong direction. The code might become bad. It might be hard to maintain it. There could be a bunch of different things, because it could be that the functionality is somewhat okay, might be super slow once you get enough users, or what it might be, and it might be hard to add new features to this. They might be more costly. So make sure you meet regularly, make sure you do small decisions and take small decisions, and work together, do it together. Okay, so who are the people in this team, and what do they do together? Well, there are different ways that this is done and different ways you can do this. You can assign roles to people, and you can give those roles responsibilities. And that's probably the most kind of typical ways, right? And you can have like team leads, and you can have tech leads, you can have UX leads, you can have QA leads, you can have product owners, and you can have scrum masters. You can have all these kinds of things. And there are pros and cons to this, of course. But I think that the most important thing that you can do as a team is to have a team agreement. Team agreement. Now, team agreement, right, is just like a contract that you have where you sign here, where the whole team agrees to work in a particular way. You decide that you're going to write code in a particular way. You decide that you're going to make decisions in a particular way. You decide to communicate in a particular way. You might be using Slack or something like that. You might be using a particular issue manager. You might be using, say that in a particular way, you're creating a pull request that you put on GitHub or whatever it might be. This is all in a team agreement, right? And it's kind of a shared view on how you should conduct your work and what your expectations are on each other. And with this team agreement, whenever there's a break in that agreement, you can point to it. Hey, well, I think we decided this. And it might be that someone is not breaking your agreement because willingly or because they want to have some illicit intent, but they might just have forgotten. And so then it says, oh yeah, we did decide. Yeah, cool. Sorry, my culpa. And it's all resolved by this, right? And so, and with a good team agreement, you don't need roles. Instead, you can share the responsibility that this work gets done, and you can resolve issues for this. Okay. So this is kind of my view on how to successfully and quite simply work in a project, software project, together with other people. You all have different skills. Some people are better at certain things. So make sure those people get to at least make decisions and work on those things. But you should also try to distribute the work so that the people who do not know something also learn how to do it. You build yourselves up, right? So if someone is really good at something, try to teach that to the other people. Because then when you will learn things from other people, because the more experiences you have, the better you will work as a team and the better you will be able to work together. Because you do want to meet regularly, you do want to make small decisions often, and you do want to work together. But how you make those decisions should come from the team agreement. So with that, I think that's it for me. And I'm sure you can ask me questions in one way or another. Thank you.